Hello everyone, this is Mrs. Lindsay Pereira. Today we're going to talk about algebraic equations. We're going to explore a lot of different things here with this. I'm going to kind of jump around in the notes. This is probably one of our longest sections in terms of kind of notes because we put a lot together in terms of this. But like I said, I'm going to skip a few different things here. And whatever I don't finish will be your homework for the rest of the class period, and that you'll have to upload for tomorrow. Okay, so first of all, an equation, hopefully from the vocabulary that we talked about earlier. An equation has the equal sign in there, right, where you compare two quantities. So the left side would equal the right side. They can be true, they can be false. So if I look at the first one here, I'm just going to call this A. And I'll go ahead and just mark all these real quickly so we have a reference here. A, B, C, D, E, keep going, F, G, H. Okay, so let's just look at the first one, A there. 15 times 5. 15 times 5, yes, that is 75, so this is a true statement. Okay, I'm going to jump over here to C. On C, we have 1/2 plus 1/3 equals 2/5. Now, when you're doing this, you actually have to convert these to have like denominators whenever you're adding and subtracting denominators. So you can use a calculator to aid you in this. If you want, pause and grab your calculator. We can go ahead and again do 1/2 plus 1/3. How do we convert it? Hopefully you remember from your lesson yesterday. Go math, enter, enter. And that converts it, and it is 5/6. We will continue to do some of these by hand, but we'll also use our calculator as well. But if you notice, that is not a true statement, so that is false. So we got one to be true, one to be false. Okay. And again, I'm just going to jump around here a little bit. -5 minus a -4. Now remember, whenever you see this, subtracting a negative is really turning that to addition. I'll do this notation frequently. Some people like to go ahead and just add that extra step in. But -5 plus 4, that's -1. And again, that is false. And then let's go ahead and take a look here at G. So now again, when I'm multiplying, a little different than adding and subtracting. I don't need like denominators, so I multiply the two numerators together, 2 times 1, and the two denominators together, 3 times 3. So 2/9 equals 2/9. And yes, that is true. The left side equals the right side. Okay. And then we have H here. So again, 18, what makes this different, once I multiply and simplify that left-hand side, I've got an inequality. 18 is not less than, but it is equal. So that's a true statement right there. Okay. So go ahead and pause a minute here. Write an equation that you feel is always true. And then again, push play when you're ready to resume. Okay, I went ahead and put an example down. I did 5/4 plus 3 is greater than or equal to 1/2 plus 1/4. I just recommend kind of challenging yourself on this. Again, it really can be anything. There's a ton of different answers for this. So your answers really can vary. And I'm happy to check yours. If you have questions, you can either email me about it or ask me during the Google Meet. Okay. Now we're going to move down to question 5 here. Okay. So we studied equations involving variables. This is what really kind of the fundamental beginning of Algebra 1 is. So equations that have only numbers are either true or false, but equations with variables can be true from values of the variable, but false for other values of the variables. And typically we're trying to find the ones that are true when it says solve. But again, if you're looking at this type of a problem here, again, I'll call this A, B, and C. We're going to do B. So given this equation, we want to test to see, do these work? Well, we are simply going to substitute in. So if I take x equals 1/2, I'm going to plug that in for wherever I see an x. So essentially what I'm doing here is I'm going to take 2/3 times a half squared minus 2 times a half plus a half. Does that equal 5? Let's go ahead and do this one out by hand, even though we do have our calculator. So I have 2/3. If I square a half, that's 1 times 1 in the numerator, 2 times 2 in the denominator. And if I multiply here, again, remember this is over 1, so I do numerator times numerator over denominator times denominator. Okay, 2/3 times a 4, numerators multiply together, denominators multiply together, and notice we can reduce that to 1/6. And then this is really just 1 plus a half. So how do we convert this? 1 is really over 1, so multiply top and bottom by 6, which would give me 6/6. A half, multiply top and bottom by 3, so that gives me 3/6. And again, my goal there was to get a denominator 6, so I could actually subtract and add all those together on that side. So I have a 1/6 minus 6/6 plus 3/6. So 1 minus 6 is -5 plus 3. That right there is going to give me -2/6, and we can tell right away. We can simplify that more, but that is going to be false. And let me put that false over here, about a half. Okay. And now we'll use our calculator for the other ones. Okay. So if we plug in 9/2, so again, let me move this just slightly so I can see my original problem. There we go. So now I have 2 divided by 3. Always put parentheses around those fractions there. And I'm going to square it. Minus 2 times 9/2 plus a half. And I could do math enter, but we don't want our answer to be a 5. So in this case it is 5, which is a whole number, so that's going to be true for 9/2. And then we'll do the exact same thing for -3/2. Now if you recall, if I just do second enter, that'll bring this equation back up again. And then I can very easily just use my arrows to come over here and make this -3. Now realize I have to enter a 3 in there without typing over this division sign. So I'm going to go second, hit the DLE key, which is in other words the INS key, insert, and then I can make that -3 and it doesn't type over my sign. So again, the negative sign is going to go over the 9. I do second INS, which stands for insert, 3, and now I just simply push enter. And yes, that one also works. So that is true. Okay. All right, so 6. All right, let me label these. I'm going to just put A, B, C, D through all these here real quick. Sorry that wasn't already on there. It just takes a moment. And I'll continue to label the next portion of it as well when I get to the next slide. Again, we're not going to do all those, but that's okay. All right, so now we want to find the values that make it a true. So in other words, typically we see directions here that say solve. Okay, or they might say solve for x. So what we have to do is undo operations. So we want to isolate this x to one side. So we want to isolate x by undoing operations. So if the original problem is adding, like it is here, we want to subtract 5 from both sides. Okay, now I'm okay if you use your calculator. Please, again, oops, sorry, didn't mean to make that so large. Also be able to do this by hand as well. -4 divided by 7 minus 5. Now I'm going to go ahead and do math enter and leave that as a fraction. Fractions are always exact, so I get that to be negative 39 over 7. And decimals are sometimes exact. Okay, so how do we get rid of this 3/4? How do we undo this operation? Well, some people might say I'm taking 3/4 and I'm multiplying by x, so I need to divide by this. And I agree with that. Dividing by a fraction, though, is the exact same thing as multiplying by its reciprocal. Because I'd get 12 over 12, multiply the numerators, multiply the denominators, and that would turn in just simply x, or 1x. We don't ever write the 1. We always typically drop it. So now I can take negative 39. So remember, if I just hit times, and again, I'm going to put parentheses. Never hurts to put parentheses around fractions. When in doubt, do that if you're not sure. And then I want to do negative 39 over 7. So I'm going to take the answer from above and hit enter. Oops, math, enter, enter. Always will convert that to a fraction. So negative 52 over 7. Okay. All right, so let's take a look here at E. Okay, now I'm going to do this problem a little bit differently than I would do some other problems that I have here. There's two different ways of doing it. Well, the first way that I see x is inside the parentheses, so I want to get rid of this number on the outside. I'm going to subtract 5. And if you notice, it's the exact same problem up here, just slightly different. So I'm going to get negative 39 over 7. And again, we're right back to where we did what we just did here. How do I get rid of this 3/4? X is inside the parentheses with the minus 2. I'm going to multiply by the reciprocal. I'm going to multiply that by 4/3. So again, this will just turn into 12 over 12. So I will simply just be left with x minus 2 because that'll turn into a 1 right there. And I'm going to multiply this by 4/3. So again, right, same thing up here. So that's going to be negative 52 over 7. I'll just go ahead and highlight this as my answer. Now I need to add 2 to that. So I'm going to go back to my calculator. Plus 2. So again, automatically brings down that answer. I'm going to go ahead and do math, enter, enter. So I get that to be negative 38 over 7. Okay. All right, so now G. Skip over here to G. Now I have a square root. X minus 2 is underneath the entire square root, so I need to get rid of the square root. But what's the opposite of square rooting something? Squaring it. So those are inverse operations of each other, so they sort of cancel each other out. 5 squared is 5 times 5, so 25. And I add 2, and I get that to be 27. So again, we're always thinking about undoing operations here. All right, when I keep going on here, I'm going to label these H, I, J. So again, we know which one we're referring to. Here's an L, kind of a script L. All right, so let's actually take a look here at I. Well, now I have this quantity squared, so what's the opposite of that? So what we just talked about in our previous problem, opposites, squares, and square roots. So I'm going to square root both sides. So those cancel each other out. So I get x plus 3 equals, here's something I want to point out. Why is that plus or minus 5? Okay, so when I take the square root of 25, most people think of it as 5 times 5, which is absolutely true. But when you're solving for a variable, you can't forget that it's also negative 5 times negative 5. So I'm ultimately solving 2 equations here. One when 5 is positive, so if I subtract 3, I get an answer of 2. One where it's negative, so when I subtract 3, I get an answer of negative 8. So that's an important little portion to remember there. When you're solving for equations, you square root both sides, you got to remember to do plus or minus there. Okay? All right, next one I want to do is K. I'm going to do this in 2 different ways. One is how I just did the problem E, I undid all those operations outside the parentheses because my variable was in the parentheses. So I'm going to add 2. Then I'm going to divide both sides by 4. So it cancels that 4. And then 64 divided by 4 is 16. And then subtract 3. The other way is to distribute. So go ahead and distribute the, let me change colors here. Distribute the 4. So I get 4x plus 12 minus 2 equals 62. So here I'd go ahead and simplify on this left-hand side. Then I would undo my operations by subtracting the 10. So I get that to be 52. And now I divide by 4. And you notice you get the exact same answer. So it doesn't really matter which direction you go with that. But again, just showing you 2 different ways of doing that problem. Okay, so let's move on here to number 7. Some equations with variables are always true, and some equations with variables are never true. We're going to look at these. I know it says substitute several values for the variables into the equations below. Determine which you believe are always true and which are never true. Okay, so let's just take a look at this one here. I'm going to call this again A, B, C, and D. If I look at A, okay, well, my first thought is I can simplify this side. If I bring through and distribute the 2, I get 2y plus 6. Now, careful here. Make sure you distribute to the negative 4. It's not negative 4 times negative 1, so that would be positive 4. And I can keep simplifying. I can combine my y's. I get that to be negative 2y. I can combine my integers, which is 10. And look what happens. It is identical to the right-hand side. So this is going to be always true. But if we compare that to C, I can't simplify that. Now, I can't factor. I know we haven't talked about factoring yet. You probably recall it, hopefully, from Algebra 1. But I can't simplify that. So this one is, again, always true, never true. So this one is going to be false, really never true, right? That left-hand side equals the right-hand side. Okay? So hopefully that makes sense. So again, we're going to skip around here just a little bit. I'm going to leave these for you guys to answer. And again, I'm going to skip on this page here. There's going to be a few problems that we skip on this, and I'll talk about those at the very, very end. So this page, we're going to kind of go through and jump down to problem 16 here. Okay. So we want to solve each of the single variable equations below. Okay. So with this one, we're going to do A here. Okay, so if we solve this, again, we need to simplify as best we can on both sides. Now, there's fractions in both of these problems. My instinct is to get rid of those fractions. I know I can distribute. I'll have a fraction here, and I'll get rid of my fraction here because I know 10 and 5 are multiples of each other. Same sort of idea. This will reduce to a whole number or integer. However, I'll still be left with a fraction here. So my first thought is to, you know what? Let me clear this fraction. So if I multiply everything by, I have the same denominator of 5. So I would take 5 times 14. 5 times 1/5. Now realize this is all one term here. So I don't have to take 5 times j. I don't have to take 5 times negative 10. I just do 5 times negative 1/5, which is going to be just negative 1. If you need to put that placeholder in there of 1, that's fine. If you just put a negative, that's fine too. Same idea here. I don't have to bring it through. I just multiply it by the 2/5, so that'll just become 2. Now I have integers that is much easier to actually work with here, so I can go ahead and distribute through, and I can start solving this equation. So I bring through the negative, bring through the 2, I'm going to combine like terms here of the 10 and 70, so I get 80 minus j equals 50 plus 2j. Now I can undo my operations here and solve this problem. Excuse me, so I'm going to subtract a 50. And I get 30 there. I'm going to add j, so I get 3j, and divide both sides by 3, so j is 10. Again, this can be done either way. You're welcome to use your calculator. You're welcome to go through the problem using fractions. I have a tendency, if I can, clear them. Okay? All right, so I would like you to actually try C. Pause the video, try it. When you're done with your problem, push play so you can check your answer. Okay, so notice I didn't quite finish this. I distributed, combined like terms, but I stopped here. If you went another step, you might get something like this. If I subtract 10a from both sides, they both cancel out. So I get negative 2 equals 2. Well, let's think about what we were doing before. Is this true? No, that is false. 2 does not equal negative 2. So when you get a false answer like this, then you get no solution as your answer. And please write out no solution, because this symbol does not mean no solution. That means null set. So don't write that symbol. Okay, just go ahead and write no solution. If it came to this point when I have 2 equals 2 and that's a true statement, then we get a slightly different answer. That answer would be infinite solutions. Okay? Alright, so let's jump down to a few more problems here. Let's look at G. I'm sorry, actually I want to go to I. Okay? Now in this case, I have a fraction here, but it's inside the parentheses, so I really do need to distribute. So when I take 4 times this, I'm going to take this in a few different steps here. This 4 and 2 cancel. Now you might see that right away and realize that's just simply 2 times that quantity, x plus 3. Either way, now I have to distribute through the 4 times the negative 5, so that's going to be negative 20 plus 14 equals 2x. I'm going to do a couple things here. I'm going to combine those, and then I'm going to just also distribute. So I get 2x plus 6, and that equals minus 6. Again, keep simplifying. I haven't even undid on operations. Hopefully you see what's going to happen here. I have 2x equals 2x. This is true. I could take it one more step and divide. I get 0 equals 0. But this means infinite solutions. Unlike our other one, we had a false statement. Here I have a true statement. False statement means no solutions. Infinite solutions is when you have a true statement. Okay? Okay, so we're going to skip ahead just a little bit. And again, some of these problems we're going to skip and I'll talk about those. But I'm going to jump ahead to 24 here. When linear equations have only one variable, they have one solution, no solution, or infinite solutions. If you have 2 variables, in these examples we have below, you cannot have only one solution. Okay, so let's first start off with this. If we check our answers, now remember these are ordered pairs, so this is x comma y. So I substitute in 4 for x, and for y, substitute in negative 3. So if I go ahead and solve this, I get 16 minus 9 equals 7. So yes, this is true. That works. Okay, so next one, if I do the exact same thing, I want you to plug those in. Pause the video, show me what you get when you plug in negative 5 for x and 2 for y. Okay, so you can see here, this first in 24, it says show it is a solution, and here's showing show it's not. Well, this is a false statement. Negative 15 doesn't equal 7, where this one is a true one. That's the difference between it being a solution and not a solution. Okay. So when we're checking these answers, we're going to dive into this in just a little bit more in a couple units. But I'm going to go ahead and start this one here, 30, and I'm going to let you guys finish that for part of your homework here. But when you're doing your table, I'm going to specifically pick a few values so we're on the same page here when you do this, when you fill in this chart. So go ahead and use these values to fill in this chart, okay? And then we'll talk about what that means in our Google Meet. But here are the problems. So your homework is to finish topic 3, but I am having you skip a few of these problems. So 11, 13 through 15, 19 through 23, 26, and 27. So if you could just go ahead and cross those off. I don't like black them out, but just cross them off in your packet and do the remaining problems that we did not finish for this. And then you need to upload that to Schoology. But otherwise, this concludes topic 3, which is solving algebraic equations.